Hello folks, how's everybody? Hope you're doing fine. Today we're going to have a great day, but not what you expected probably. First I want to remind everyone we have a conference in Lusaka, Zambia. Okay, you can sign up for it at rationalschool.com, and it'll be the adventure of your lifetime. So beg, borrow, and steal, whatever, make it to Lusaka, okay? You want an exotic vacation, this is a good time to have one, okay? The other thing I want to remind people, we uploaded a book the other day. It's a free book. You can download it anytime you want. It's at ropehypothesis.com. You go to books there, and you can download it, okay? And it gives you an introduction to the rope model of light, the rope hypothesis, okay? And one of the things we're looking for is for people to email us if they have a second language, if they have another mother tongue. Like in my case, I have two mother tongues. Well, someone else might be able to make a good translation into some other language. And if they do, well, we would really appreciate, the translation of the rope hypothesis into another language. And yeah, you can email us at tokakaka@hotmail. Let me put that up there again. You can email us here at hotmail.com, okay? And if you are interested in translating book. Okay, so what's the deal? Today I was going to talk about good old Aristotle and Euclid. I was going to continue with the subject of infinity, and I'm going to have to postpone that until Wednesday. I had a series of questions come up, and I want to address those questions today because they go to the heart of what science is, what physics is about, and also what the rope model is about. So, these are like the foundations, and so I think the questions are important. That's one issue. The other issue is that, these comments, they represent what the majority of people believe or think out there. And that's another reason we need to address these issues, okay? Okay, so let's get started. Here's the first comment, okay? Fellow says, mine, right? Scientific process does not allow for new experimentation or observations. He, unfortunately, refuses to acknowledge the experimental physicists who do all the hard work, poor souls, that leads to those observations that allows him to draw conclusions. Bill's version of science assumes we already have all available evidence. That is why he puts experimentation, investigation into his religious basket. Okay, mighty words. Okay, how do we address that? Okay, let's look at this. Deserves an answer. Okay, and here we have John Baez and his crackpot index, which he applies to all distance. And the first one is that it doesn't address, there's no provision for hard work in science today. He says 10 points for beginning your description of your theory by saying how long you have been working on it. 10 more for emphasizing that you worked on your own, okay? So hard work doesn't cut it. If you have an irrational theory, we don't care how much hard work you put behind it, and, it's still irrational. So hard work doesn't cut it. But let's address some of those other issues there. In rational science, there is no provision for experimentation or gawking. Some call it observation, we call it gawking. Okay? If you gawk, you're not a scientist. So observation is not part of science. Okay, a lot of people have trouble with that. They say, well, how do you know what to explain if you haven't observed it? Well, again, I keep giving the examples and some people simply don't get it. Stephen Hawking never observed a black hole. That doesn't mean he cannot theorize about it. And I'm sure Einstein never observed space-time, okay, especially with his two eyes. So you don't need to observe anything to be able to theorize about it. They're not related, okay? But you can see that there's no provision for experiments either in there. Where do you see a provision for experiments? That's the reason, experimental and observations and all this stuff, investigation, that doesn't have anything to do with science. In science, you got to explain, because that's what science is. Science is a body of rational explanations, okay? So let's go with the second issue raised by the same gentleman, but again, he represents quite a bit of people out there. That's why I like to put these comments up there, because I want to address them. I want to make sure they don't go flying by and you get blindsided to them. No, I like to address these things. His version, mine, right, of science is very similar to how religion itself explains the universe. I'm a religious fanatic. I'm a religionist. Good. Okay, there is no room for retesting the assumption, because, as he says, it is not science. Yes. Retesting, whatever, is not part of science. We don't retest, we don't verify, none of that. We don't prove, okay? You have to believe them, just like religion. Whether you believe my mechanism is your religion. True. Bill does not allow you to question his assumptions. False. Okay, so let's put that in the proper perspective so that we're all on the same page. Okay, we'll make sure we all understand what we're proposing. Okay. In science, the crowd takes an assumption at face value in order to understand the theory founded upon it. Okay, so someone makes an assumption, you say, okay, we concede your assumption. Okay, now explain the theory. Now you have to base your theory on that assumption. So we concede the assumption. You can talk about angels if you want. We just want to listen to what you have going through your mind. Then we're going to go further, and here you can see the reporters can and should question the assumptions at the end of the talk. Okay, if the assumptions are shown to be irrational, the theory falls outside of science. Okay, so the issue here is that not that we don't allow people to question. Okay, the issue is that we use the assumptions in order for you to understand the theory, the mechanism in case of physics. Okay, you want to understand the cause, what causes gravity, what is the mechanism underlying magnetism. And so we begin with an assumption. The assumption includes, as we just shown a second ago here, let's see if I can find it again. Where did I put it? Give me a second here. Here it is. That's the assumption. The hypothesis is the synonym of assumptions. It presents the objects, the definitions, and the initial scene. Okay? When you question them, yeah, you can question them. In fact, afterwards, you let the guy give the presentation, then you say, look, we got a problem with your assumptions. No problem there. You can question the assumptions. What you can't do is believe in them. So he's wrong about that. We don't believe in assumptions. We take them at face value to understand the theory founded on it. Okay? Mathematical physics does it exactly in reverse. They don't allow you to question the assumptions before or after. Never. You're not allowed to. Here you have a case in point. Okay, you have Bayes' crackpot index again. 10 points for each claim that quantum mechanics is fundamentally misguided. You can't question quantum mechanics. It's a done deal. Okay, 10 points each. Claim that special or general relativity are fundamentally misguided. So you can't question those assumptions anymore. They were theories, they became proof, and now they're used as assumptions. You can't question the assumption anymore before or after the presentation. And no, that's not what science is. In science, we're required to question the assumptions if we have a problem with them. Okay, so yeah, we do question the assumptions. Okay, and Bayes says you should not question the assumptions of both quantum mechanics and general relativity. And here you have I showed this the other day. Here you have a couple of bozos, Mr. Bohr, Leo Susskind, and Richard Feynman, and they tell you we don't understand quantum mechanics. Okay, essentially. I'll just read the last one from Feynman. I think I can safely say that nobody understands quantum mechanics. Do not keep asking yourself if you can possibly avoid it, but how can it be like that? Nobody knows how it can be like that. The more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics has given up on that. Okay? And here's Bias again, just in case. In his crackpot index, he says 10 points for arguing that while a current well-established theory, meaning quantum and general relativity, predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism. In other words, mathematical physics, so-called science, which this fellow apparently defends, okay, doesn't explain any mechanism. There is no mechanism in all of mathematical physics and all of so-called science. Big word for all these people. So there are no scientists out there. Scientist is not a guy who develops gadgets. That's technology. Scientist is not a guy who does equations. That's a mathematician. That's a language. That's like saying you know Chinese. This guy knows mathematics, a symbol, language of symbols, of hieroglyphics, that he can establish relations with that. So what? What does that have to do with science? Science, I need to explain how gravity works. That's what I need to be able to explain, that mechanism. And none of these guys can explain. They tell you right in your face, we don't understand how the universe works. We don't pay attention to mechanisms, so we do not explain. Or as Professor Emeritus Donald, what's his name? Simonek of, Lock Haven University in Pennsylvania. He says, science doesn't explain. Science describes. Why? Because the only thing math can do is describe. Math has no power to explain anything. You cannot explain gravity. You cannot explain magnetism, the cause, the mechanism. All you can do is describe it mathematically, but you cannot explain it. And that's why mathematics has turned into mathematical physics, and mathematical physics is all descriptions. There is no explanation, no rational explanation. And when you confront these people, they say, well, we know we can't explain, so what? That's not science. Science is the equation, the description. That's the problem. Okay. So here we have another comment from this individual. It says, a scientific thought process is a continuous process of learning. Learning? You mean like memorizing? Is that what it is? We go to school, and they say the teacher tells you read from page 45 to 50 because I'm going to test you on Friday. And so you read it, you memorize it, you get an A on the test, you forget it 2 days later because you passed the test. Is that the process of science? Is that what learning means? But then you get into what he continues there. He says, because in science we can't prove. Well, thank God he said that, yeah. In science we can't prove. But then he says, until we can't falsify the hypothesis. Falsify? That sounds like proof. Either prove or falsify, right? And if you can't falsify, I guess you proved, right? What is the Popperian falsifiability where he gets these terms that he doesn't understand? A statement is falsifiable if some observation might show it to be false. Okay, false? That's an opinion, that's a belief. Is God a false or true? Is space-time false or true? Is a particle at two places at once true or false? I mean, how are you going to falsify that? And for example, all swans are white is falsifiable because here is a black swan, shows it to be false. Yeah, that statement, the statement, right? So that's not a theory, okay? That's just an assumption, okay? And so what you're not really falsifying the assumption. You're saying that it is irrational or it's an incorrect statement. Now you want to call that falsifiability, fine, but that's got nothing to do with what this individual is saying. He's falsifying the hypothesis. He's thinking of the theory. He's saying that for him, a hypothesis and a theory are synonyms. A hypothesis is just a theory that has not been tested so well. That's in general the notion all these people have. So let's go with falsify first, okay? Here it is. How do you falsify this? Here you have Stephen Hawking. He says that there are such things as black holes. Black holes are zero-dimensional. There's no, like he says, there's zero size. And how do you falsify that? How do you falsify a zero-size object? Well, what are you supposed to do? Go out there and bring it in? You know, how are you going to drag it in if it's a zero-size object? And that's what he says Chandrasekhar proved and got a Nobel Prize for proving that stars can collapse beyond their structure. And how do you falsify Niels Bohr's disciples who say that a particle can be at two places at once? How do you falsify that? I mean, you run a test where a particle is supposed to be at two places at once? Prove that. I mean, you know, what these guys have done is simply infer. This is their conclusion based on the particle hypothesis. They say, well, the only way you can explain it with particles is that the particle is at two places at once. That's a different story than saying that, you know, that you have proven the existence of particles first and that a particle can be at two places at once. And then, so what you need to go is to this word hypothesis, okay, that this fellow is using. Again, he thinks it's a theory. And here you have different references, different ideas, different notions you'll find on the internet about what a hypothesis is. And no one has figured it out in the last 10,000 years. No one knows what that word means. And here you see objectives. This is one comment. State the purpose or hypothesis upon which the project is based. So here this person thinks it's a purpose. Another person thinks it's a question, a statement in statement form. For example, sargassum inshore will have fewer organisms than sargassum or offshore. Okay, just a statement that you want to prove or some, again, a purpose, maybe something you want to do. Then you have another one, a tentative guess or hunch. In other words, a prediction. Is that what a hypothesis is? A prediction? I mean, if it's a prediction, how can it be a question or a purpose? And here you have another one. It says something taken to be true for the purposes of argument or investigation. An assumption. Is an assumption the same thing as a prediction? As a tentative guess? As a question? As something you want to investigate? Is that what an assumption is? A hypothesis is an explanation with some evidence and testing behind it. So is an assumption the same thing as an explanation? And then we have another one. Any physical theory is always provisional in the sense that it is only a hypothesis. So a theory is a hypothesis. So, and then the last two, a tentative theory about the natural world or data analysis. So you get all these notions of what a hypothesis is. None of these people have ever figured out. No, a hypothesis is the set of assumptions that you have to make in order to understand a theory. And the way we do it in science, in genuine science, you present the objects. That's part of the hypothesis. You have the set of definitions. That's part of the hypothesis. And then you have the initial scene or the first frames of the film. You know, the detective goes to the crime scene. He sees a body on the floor with a knife on the back. First, he describes the scene, okay? And so that's the hypothesis. That's the starting point of his theory. And if you don't understand what a knife is or what a body is, well, then he presents those as Exhibit 1, Exhibit 2, the objects. And then he's got the definitions. You don't know what the word crime means, what stabbing means. Okay, so he defines it. That's the start. That's the hypothesis. Not all this nonsense that these people have come up with, which is a tentative theory, a tentative explanation, a prediction, an assumption, and all this mixed together, and everything is a hypothesis according to these people. Okay, so here's a comment that I found in the dictionary, which I kind of liked. Okay, about what a hypothesis is. It all comes down to belief in mathematical physics, in so-called science. Hypothesis is a proposition that attempts to explain a set of facts. A scientific law is a hypothesis that is assumed to be universally true. True? True to whom? I mean, is God a truth hypothesis? How many people should we count? 4 billion, is that good enough? How about 6 billion? Or should we wait till all humanity believes in it? When does it, become more, when does it become true? So this word true is just belief. It's just an opinion. And that's not where it stops. It continues. A law has good predictive power. Predictive. We don't do predictions in science. That's astrology. New hypothesis inconsistent with well-established laws. Well-established by whom? I mean, by the Vatican? Or was it by the mullahs in Iraq? Who established these laws, so-called laws? Are generally rejected. Yeah, they reject anything that goes against quantum mechanics and general relativity because those are established laws by whom? By a group of monks that are in Cambridge and Harvard. That's all it is. So they've established these laws and now you got to abide by these laws. Okay? A theory is a set of statements, including laws and hypotheses, that explains. I thought they just said that they couldn't explain. So what? They don't do hypothesis in general what is it, mathematical physics, because they don't explain. They claim they don't explain. They say descriptions is what science and math phys are about. So obviously they're not explaining. So I don't know why they put the word explain in there. Explains a group of observations or phenomena. Broad acceptance by whom? Who is accepting? Does that mean it's an opinion? It's whoever believes? Is that what this is all about? Belief? Broad acceptance of a theory comes when it has been tested repeatedly on new data and been used to make accurate predictions. Again, what does predictions have to do with explanations? And we're talking about an accepted theory. What's that got to do with a prediction? A prediction is a description. Anything you predict is always a description. You say, my horse is going to win, number 5. And your horse gets there first, so you made a correct prediction. What did you explain? All you did was describe. The moon's going to cause an eclipse tomorrow at 2 o'clock. What did you explain? All you did was describe. But if you can explain, now you're talking about the past. Now you're drawing on your experience. You're not predicting, you're looking backwards, not frontwards. You're thinking of something that you already have experience with. And that's why you can explain it. Explanations only have to do with the past, and that's all that science has to do with. Predictions have nothing to do with that. So, again, all these have contradictions in their statements and their notions, okay? Says, broad acceptance of the theory comes when it has been tested repeatedly, all the way to predictions. All the hypotheses of relativity have now achieved the authority of scientific laws. So you got to believe it or kill yourself. You have to accept this. See, you have authority. Now you have to bow down to authority. Again, belief. Some people believe this nonsense that there's a 4-dimensional space-time within which we live, right? And they say, well, you're not supposed to take any of that literally. We can't explain it, but here's the equation. I don't care about your stupid equation. I want to know how this universe works. For this, I need to know why the Earth doesn't fly out of the sun, out of the solar system. I want to know why the moon that goes around the Earth doesn't fly out of the solar system. That's what we need to understand, the mechanism. These people are saying that space is warped. Space-time is warped. That means time is warped, and time is holding the Earth from running out of the solar system. That's what they're telling you. And so they say, well, that's just an analogy. Well, an analogy for what? What was the point of the analogy if you're saying that time is warped? And time is a concept. What do you mean time is warped? What does that mean? And yeah, they drive it to you through authority. Okay. In some cases, a theory becomes so completely accepted by whom? By Harvard and Cambridge. It stops being referred to as a theory. Now it's a fact, a proof, whatever, knowledge. Okay. So yeah, space-time is knowledge. We can't criticize it anymore. It's been proven according to these people. Okay, there's no chance to challenge it. And it's interesting. I looked up. Where is it here? Here are the religions of the world. Okay, and you can see that most people believe in a God, right? Some call it Allah, God, whatever. It doesn't matter. They believe in a single deity up there, right? And then you got number 3. You got what is it? 1.1 billion people are apparently atheists, agnostics, a little bit of everything there. They are non-believers. Okay, are they? No, they believe in other nonsense, worse nonsense. They believe in mathematical physics, most of those. Okay, so you got a situation where the mathematical physics laughs at the other guy and says, "You believe in God? Are you kidding me? Show me where God is. Prove to me that God exists." And the other guy turns around and says, "Well, what is this 4-dimensional space-time that you cannot even imagine? Or how is a particle at 2 places at once?" And this guy what's he going to say? How is he going to explain that? What explanation does that possibly have? So are those so-called non-religious folk any better than the so-called religious? No, they're all religious. They're all religious because they're all irrational folk. You're talking about more than 99% of humanity is irrational. Completely irrational, because one guy believes in God and spirits and miracles. The other guy believes in even worse stuff. He believes in space-time, that you can travel backwards and kill your grandfather forward and kill your grandson, in black holes that are 0-dimensional. What is this nonsense? What does that have to do with rationality and with science? So yeah, all these people are religious. There is no difference between them. Okay? And people should keep those things in mind when they're looking at, if you're into science, you should keep these things in your mind, in the back of your mind. Okay, here's another comment by this gentleman. And again, says definitions are important. And the first thing you find, in geometry, they never define point or line. They say they're undefined terms. Nobody has ever defined the word energy. We don't have a definition for the word mass. Nobody knows what mass is. It's not the quantity of matter, by the way. So if you have this in the back of your mind, that's what you learned in high school. That's been overthrown. Okay, so you better look at that up. And when you try to define terms like, critical ones that make or break any theory in physics, like the word object, you can't do physics without an object, okay? And you try to define those terms very rigorously, people start trembling because it destroys their religion. And so they dismiss it as semantics. So yeah, definitions are important except in so-called mathematical physics, except in science. Science as equal to mathematical physics. In genuine science, they are important, yeah. And so I define, there he says, object, that which has shape, exactly. And then he says, well, a shape is a 2-dimensional object and form is a 3-dimensional object. That's in ordinary speech, not in science. In science, we only have black or white, okay? And here, let's see, I've got a little thing here to compare it against. Okay, so that you can see what I'm referring to. In physics, there is no gray. In physics, there is only black and white. Sorry, we're all racist in physics, okay? It's only black or white. You got to make it very clear, very crisp, okay? A word alludes to a concept or to an object. There's no other type of word in the entire dictionary. It either alludes to that which has shape or to that which doesn't, okay? If it doesn't, it's a concept. Very simple. You say love is a concept. Why? Because you can't draw love. You can't draw intelligence. You can't draw energy. You can't draw force, field, time. None of those words you can make a drawing. You cannot sketch it. You cannot make a picture of it. That's why they're concepts in general. That's a good rule of thumb. Object, a table you can draw. You can draw rock, you can draw a tree, you can draw any of those things. Those are objects. So if you can't tell the difference between an object and a concept, you need to see a psychiatrist, okay? In ordinary speech, shape is not equal to form, but in physics, shape and form are synonyms, okay? So there is no difference between shape and form because we need to define the word crisply for the purposes of of physics. And, none of these other things, criteria, can be used in physics for the definition of the word object. You cannot use see, touch, which is the dictionary, the definition you'll find in many dictionaries. You cannot use mass, volume, motion that it's made of, something we call mereology, or temporal parts. It can't be the subject of a sentence. That's not, you can talk about motion. Motion is not an object. You can talk about orbit. Orbit is a verb for the purposes of physics, okay? So you can't use any word that in ordinary speech you use as a subject of a sentence or as a noun. Those don't automatically go into physics as objects, okay? Not that which has color, not that which exists, and not that which is 3D. The only universal of objects every object has is shape. And so we don't distinguish between shape and form, whether it's 2D or 3D, that's a second matter. We haven't gotten to that far because the first word we have to define in physics is the word object. So we can't go and say, well, how many dimensions does it have? We haven't reached the word dimension yet. We haven't defined the word dimension. Okay, so no. The only property or attribute, whatever, that all objects have is shape. That you can put your money on. Okay? And that's the definition for physics. And of course, this destroys a lot of religions. Just ponder it for a second. God, does he have shape or not? If God doesn't have shape, he's a concept. It's a concept. And if God has shape, then God's an object. And so now we have a little bit of problem because now the guy has to decide. And of course, a lot of religious people hate that type of predicament because they can't answer that. And a lot of them will say stuff like, well, if I knew what God was, he wouldn't be so great, and they get around it any way they can with a little bit of word wizardry, right? But no, God either has shape or God doesn't. And if God doesn't have shape, God is a concept, and you're praying to a concept. Hopefully the concept is listening, got ears, Here's another comment. This gentleman, this puts it in a lot of perspective. He says, looking forward to the time when we skip the history lessons and delve into the details of the rope hypothesis. My God. Well, it shows that this person has a very short attention span or some mental problem, I don't know. And all I can do is put this. It explains a lot about him. Maybe he suffers from one of these ailments. Maybe he's got attention deficit hyperactivity disorder, ADHD, or a short attention span, right? Superficial mind or Twitter mentality, one-liners, that's all he can handle. Maybe he's an Asperger or he's got autism or something, or the onset of Alzheimer's. I mean, maybe that's why he can't keep up. You need to have a history lesson to put everything in the right context. You need to know where the idiotic word infinity or infinite came from, which we're going to get to in a minute here. Who came up with these idiotic words? I mean, there is no such thing as infinity as applied to physics. You can't say whether the universe is infinite or finite. Okay? These are irrational statements, irrational questions. You cannot say, is the universe infinite? Is the universe, finite? Universe is a concept. They can't be finite or infinite. Okay? And people have to, get into that habit of the language. The language is absolutely crucial here. Okay? And in fact, that's the question that he came up with next. He says, for anyone interested in learning about the different types of infinity as defined by mathematics, and he gives a reference there. So you go to the reference and you find this girl who's got a very sexy voice. So if you're into sex, hey, you may want to visit that site. But she's a dumb blonde. Okay, forget it as far as physics is concerned. Let me tell you why. She goes in there and she does this. She puts Hilbert space and she talks about the infinity of dimensions. I call it the infinity of dimensia. Okay, because she puts all these little arrows. She says those are dimensions and they're infinite dimensions. And dimension has only two properties, as we will explain in the future lecture, and that's orthogonality and direction. And none of these are orthogonal. In other words, all those have less than 90-degree angles. Okay, and so they can't be infinite dimensions because none of those are dimensions. And again, what happens is all these people confuse number lines for dimensions. They think that they call number lines dimensions, vectors, and coordinates. And so people say, oh, they're talking about dimension, four-dimensional space-time. No, it's four-number-lined space-time. Space-time is not a dimensional thing. It's a number-line thing. They're telling you how many number lines you need to locate a point. And the other problem with number lines is that they don't have direction. Number line has no direction. It's not a property of number line, just magnitude. That's all a number line has. And so she ends up putting all these in different directions when number lines don't have direction. And she calls them dimensions. Multi-dimensional universe, infinite dimensions. Just nonsense words. She never even pondered the issue when she studied, if you call that. So she just memorized whatever they gave her. Okay. And let's address this issue. Let's put it back up here again. He says, let me put this other one here as well. He says, he's talking about infinity, and he says, one application of infinity, we don't know whether the universe, everything that contains all matter, is infinite or whether it has boundaries. Well, we start out by saying that there is no gray. Everything's black and white. Either it's an object or a concept. And in the case of the universe is a concept. The concept universe stands for space and matter. The concept universe has two. It's a relation between space and matter. That's what it is. And the first thing you got to determine is whether you're talking about matter or you're talking about space. So the question is whether space is a physical object, a medium, a box, a container. I don't know how else to put that. Is it a body of water? I mean, what is space? If space is an object, we can talk about the object being finite. In fact, it had better be finite if it's an object, because that's the definition of the word object, that which has shape. Something that is infinite is not an object, because you can't visualize its shape. It's infinite. What is it? Is it growing as you try to see it? I mean, you have to conceptualize it on the board. So anyone who believes that space is a physical object just has to make a picture of space on the board and identify the entity, the medium, whatever, that encapsulates space. Okay, what encapsulates space? Thought? I mean, water? What do we have out there? Another dimension? Is that what encapsulates space? So this is a conceptual issue. We don't need to send a rocket out there to the edge of space to find out what's out there. No, this is a conceptual issue. Just draw it on the board. We want to see what's in your mind. If you say space is a physical object and the stars and the atoms and everything are within this container, then draw the container and show me what's outside the container. And you can't say, well, that's unscientific because we have no way of proving or demonstrating what's out there. It's a conceptual issue. You just have to tell me what you're going to call that. Call it X. What is X? Is it about what contains X? And then what contains that other thing that contains X? And so on down the line. And that's why it's an unending story. You can never say that space is a physical object and that it's finite and it has something surrounding it. It's an irrational statement. Space is nothing. That's the problem. And, when you treat space as nothing, and nothing being that which does not have shape, okay, then now you can make sense of the universe. And so here's my first reply to that, okay? So let's see if we can summarize it here. If the universe is a medium, container, thing, object, then it has shape, borders, boundaries, surface, by definition, because that's the definition of the word object. A thing is that which has shape. Okay? The proponent is required to identify the entity, medium, thing, object that surrounds, encapsulates, and gives shape to the universe or to space. Draw it. I need a drawing. I need for you to put it on the board and identify what's on the outside. Whether the number of atoms, particles, planets, stars, galaxies keeps going on forever, in other words, incessant counting, is a separate matter. with respect to the size and shape of the universe, but it's easily resolved. If the word universe alludes to a concept, then universe is neither finite nor infinite. Concepts have no shape, size, or volume, and therefore do not enjoy the benefit of being qualified or modified by adjectives. If space is not a physical object, you cannot qualify it with an adjective. You cannot use adjectives on what is not a noun for the purposes of physics, and only objects qualify as nouns for the purposes of physics. Let's get that one straight, okay? And here's a finite universe, okay? Here's a pictorial thing of what I just talked about. Here's the finite universe, okay? And I need for you to identify the white stuff. If space is the black stuff or the dark stuff there and all the stars in it, and you're saying that the universe is finite, I need to identify the white stuff, okay? And if space is infinite, as you think it is, because it's some kind of infinite object of sorts, whatever that could possibly mean, because if object is that which has shape, then there is no such thing as an infinite finite, an infinite object, okay? So yeah, we have a contradiction that has to be resolved on the board. It's a conceptual issue. We don't go out there and start doing a test and experiment to try to prove something. No, this is something you got to show here on Earth, okay? And so yeah, the finite universe has a big problem, and the infinite space also has a problem because infinite is an adjective. You can only apply it to things, and space is not a thing. It's a concept. Space means literally nothing. And what does nothing mean? That which has no shape. Okay, so we have all this matter floating around in that which has no shape. So that which has no shape, you cannot escape. Not even God can escape that which has no shape. There's no border to cross, okay? There's no boundary that he can say, well, what's on the other side? I'm going to go over there. Aside from the fact that if he goes over there, he probably loses his shape. God becomes nothing because, you know, if he thank God to space that we have shape, okay? It provides a contour to our bodies. Okay, so what does rational science propose? Well, we propose a single closed loop thread, okay, a single thread. And what is this? It means the black stuff, that's space. What is that? Nothing. Absolutely nothing. What is nothing? That which doesn't have shape, okay? And the single thread is all there is. That's what we are proposing. We're saying all the matter in the universe eventually comes down to a single thread. If we could entangle every bit of matter, this is what we would end up with, okay? That's our starting point, really. Okay, and then what happens? Well, what happens next is the thread morphs, you can say it twines around itself gazillions of times, and it forms atoms, which later on form stars and planets and whatever, bigger stuff, gases, and that's what we end up with. And here's the construction of the atom from this thread. Let's see if I can get it bigger here. Okay, here's the construction. You have the thread. It twines around itself, then it goes around, forms the atom. That's a cross section, by the way, so that you see it in 2D. And that was made by Mr. David Robinson. He did a pretty good job there of illustrating that. And so you have all these atoms, right? And so what we end up is with this universe that looks more or less like this. It's all interconnected. You can think of those as just a bunch of atoms. You can also think of all those as every galaxy in the universe. Either way, it doesn't matter because the concept is the same, okay? The notion, the idea. God, you know, if he wants to exist, he should really be one of those atoms. But you can argue that God is outside the universe, outside that mesh, okay? He's outside matter somewhere. Fine, but God had better be in space because space has no boundaries. And so God cannot escape space. There is no boundary to cross in space, okay? And otherwise, you got to make sense of space before you talk about, you know, whether God can leave, you know, space or not. And then the other issue is, again, I don't care where God wants to hide. There better be a direct line, distance from my chest to his chest. I don't care where he can hide in the 20th dimension for all I care, right? But there better be a straight line from him to me. Okay, so God has no way of escaping my distance. I can catch God with my stick, just my straight stick. I'll point to God anytime, just tell me where he is. I should be able to point to good old God. Okay, another comment. This was made by another gentleman, and I want to address this as well. And he said, the surface of a sphere is infinite. We were dealing with infinity. Is the surface of a sphere is infinite? No, absolutely not. You can see that it's finite. It just ends there. And the question is, what do you mean infinite? What he's saying really is this. Let's see if I've illustrated here. Okay, and this is what he really means. He means you can run around the sphere eternally, forever. Okay, that's not infinity. What that is incessant. And people confuse infinite with incessant. Okay, that's the problem. It's a question of language. And you might say, Bill, you're doing semantics. No, you got to keep the words right. This is not infinite. Infinite is an adjective. Incessantly, like in this case, walking or running incessantly around the sphere, that's something else. You could also argue that the sphere has infinite locations. Again, wrong usage of the word. What you're saying is that you're going to count incessantly all the locations that any object has, for that matter. Between any two locations, you can find another one, for sure. Okay? It's just a question of getting a bigger microscope and seeing, between two locations. So counting locations, is that what you want to do? Because you're not counting apples, you're counting an abstraction, the location where something could be in. Counting locations, yeah, you can say that it's incessant counting, not infinite locations or infinite points. So we got to keep the language straight. The word infinite can only be used in the context of objects. There are no such thing as infinite objects anywhere in the universe. Okay? And the number of, in fact, according to the rope model, the number of atoms, I wouldn't like to use the word atoms, but we can say the amount of matter is fixed, constant. It doesn't change. Okay? And that's a long story, but it doesn't change. We always have the same amount of matter because there's only a single thread in the universe, closed loop thread. And it doesn't grow bigger, it doesn't stretch, it's not an elastic thread, it's just the same amount forever. Forever and ever. From ever and ever to ever and ever. Okay, both directions of time for that matter. Okay, and then there was another comment here, and it was the same fellow, I think. And he says, time equals motion. Absolutely not. Okay, a clock is not a boy running. Okay, seconds is not equal to meters per second. But let's put the correct definition so that we can use them consistently. The issue here is, again, it's the issue whether we have a rational definition or an irrational one. If we're going to use the word time, which we don't use in science, that's used only in the religion of mathematical physics. We don't use the word time in science. We have no use for it because time is essentially a description. Okay, and we have to explain, not describe. And so here is a pictorial representation of these two. What is motion? Motion involves one object moving with respect to others, whereas time involves one object moving with respect to another moving object. We're comparing the motions of two objects. Time requires memory. Motion does not. Motion you move by definition. Okay? If you occupy two or more locations, you have moved in physics, for the purposes of physics. Time, that's not sufficient. You need memory because you need to compare the motion of the moon against the motion of something else. For example, the earth. Okay? When you compare two motions, now you have time. Otherwise, you don't have. If you're just comparing motion, the moon is the only object in the universe and it's moving, you have no time yet, because you have nothing to gauge it against. The only way you can do that is a motion of something else. Then you have time. You need memory for time, and that's what makes it different than motion. Okay? So no, time and motion are not the same thing, not the same concepts, not the same notions. Okay? And here's my second reply to that, which is essentially the definition. Okay? And goes like this. Let me get myself back in here. Okay. So we have motion to or more locations. That's what motion is. So you move by definition. If you meet that criteria, or criterion, I guess, two or more locations, you have moved according to physics. Time, no. And I divide that in quantitative and qualitative time. Qualitative time might have some purpose in physics, I don't know. Before, after, yesterday, today, that's qualitative time. That's different than quantitative time, which is what the mathematicians use, which is a numerical or quantitative, right? Quantitative relation established between two motions, one of which is a pre-established standard. You need to have first the meter or the second or something before you can talk about quantitative time. So time and motion are not synonymous first. Quantitative time requires memory and it requires two motion. Okay? So no, for the purposes of at least rational physics, we have no use for time, but if we're going to define time, that's what we've been talking about all these hundreds of years when we mentioned the word time. It's a comparison of two motions. Okay. With that, I'm going to see you on Wednesday, and we'll continue with Mr. Aristotle and Euclid. We're going to get back into the ball game. We're going to look at infinity. There's a little more infinity to cover, so please bear with me. Hopefully this gentleman goes to see a psychiatrist and maybe take some pills or whatever. He can withstand the history lesson. It's part of the job description. You need to know a little bit of history if you want to know how we ended up with black holes, Big Bang, and other nonsense that we have today. You need to take it back all the way to the Greeks, no doubt about it. You need to lay the foundations of how we got here. And he wants to skip all that because, it's boring, and I don't have the mental capacity to withstand all this stuff, and what can I say? Anyways, we'll see you on Wednesday. And if any of you can translate the book, please contact us at hotmail.com. Okay? We'll see you on Wednesday. Bye-bye.